Hello friends, welcome back to my channel. Today we are going to see one of the interesting and important topic in an organic chemistry, that is chirality. So there is a many confusion regarding the chirality. So in this video we are going to see the whether molecule is chiral or achiral in nature. Let's begin today's video. For chirality we have to see the what is the meaning of chirality. The chirality is related to the mirror image and non-superimposable. So the definition is molecule which has non-superimposable mirror image of each other are said to be chiral. This chiral word is defined from the Greek word which is meaning of the hand. So let us see the example. What is the chirality and achirality in an organic compound? Consider your left and right hand, which are the mirror image of each other. If you try to superimpose left hand with the right hand over the right hand, it cannot give the superimposable effect. So in this case, when the mirror image are non-superimposable on each other, are said to be chiral. Let us see the another example. This is the flat bottom flask and another one is its mirror image. If we try to superimpose the initial with the mirror image, we get the superimpose effect. So in this case, it is known as the achiral. When its mirror image is superimposed which imposable with each other, it is known as the achirality. So in the example of hands, the left hand and right hand are mirror image and that is known as the enantiomer. So this is defined as the pair of enantiomer. So another question is why is one molecule is chiral and another is not? So the answer is symmetry operation. In organic chemistry, plane of symmetry is the fundamental symmetry operation which defines the chirality in a molecule. Again, consider the example of flat bottom flask and hand. In flat bottom flask, we can pass an imaginary plane of symmetry dividing the flat bottom flask in two equal halves. So it is said to be achiral. So when there is an plane of symmetry or an imaginary plane of symmetry divide a given compound into two equal halves, it is known to be achiral in nature. Let us apply this symmetry operation on the example of an hand. If we try to pass a imaginary plane of an symmetry over the hand, there the two half form are not equal in nature. So in this case, we will tell that the hand is chiral in nature and it doesn't have any plane of symmetry. Let us apply this fundamental in some of the organic molecule which defines the chirality in organic chemistry. The first example is the bromochlorofluoromethane. So in this case, if we try to pass an imaginary plane of symmetry over the hydrogen, carbon and fluorine atom, we will not get the two equal halves since one half will have bromine substitution and another will have the chlorine. Let us see this example in three-dimensional view. So this is a bromochlorofluoromethane represented in the wedge and dotted form. And this is its mirror image. If we try to rotate the mirror image in 180 degree, we will get the given compound. So if we try to superimpose this molecule over each other, it will be not superimposable on each other. In the parent compound, the bromine is below the plane, and in the resulted compound, the chlorine is below the plane. So in this case, when there is no plane of symmetry in an organic compound, it is said to be chiral in nature. Let us see the another example, which is dichlorofluoromethane. In this case, if we try to pass a plane of symmetry, we will get the compound divided into two equal halves, both having chlorine substituent. Let us see in the three-dimensional view. In this case, this is our wedge and dotted form. This is mirror image. If we try to rotate its mirror image into 180 degree, we will get the parent compound back having same substitution pattern. The two, one of the chlorine is below and another one is above. In the parent compound, there is a similar substitution. One chlorine is below and another. So when there is a plane of symmetry, molecule is said to be achiral, and where is no plane of symmetry, molecule is said to be chiral in nature. So let us see some of the example where we will see that the molecules are chiral or not. These are the for example. The first one is glyceraldehyde. It is chiral in nature. The carbon shown in the blue arrow is chiral. This is the example of alanine. It is also chiral in nature due to there is no plane of symmetry can pass over this chiral carbon. Similar is the lactate and the enantiomers. Another example is of the achiral molecule. Let's say dihydroacetone is achiral. We can pass the imaginary plane of symmetry over this carbonyl compound, carbonyl carbon. Similar to the citrate, we can have the imaginary plane of passing through the chiral carbon, carbonyl and hydroxy group. Since the pyridoxine doesn't contain any chiral carbon, it is achiral in nature. Another is the pyruvate. This one is the glycine. And this one is the dopamine. In the below three example doesn't have any chiral carbon in their substitution. Even though if we talk about the heteroatoms such as phosphate and nitrogen, these are also said to be chiral if they don't have any plane of symmetry passing through them. The first example of the phosphate oxide. In this case, we can pass a plane of symmetry through the oxygen, phosphorus, and carbonyl oxygen. So phosphate oxide is said to be achiral in nature. If we label the oxygen in a phosphate ester with an oxygen isotope such as oxygen 16, 17, 18, we cannot pass the plane of symmetry from an oxygen, phosphorus, and carbonyl oxygen. In this case, the label phosphate ester is said to be chiral in nature. Another interesting example is of the phosphate triester. In this case, the three ester substituents are different in nature. So we cannot have a plane of symmetry over here. So in this case, the phosphate is said to be chiral in nature. In case of nitrogen, if you have the quaternary ammonium substitution on the nitrogen with all four substituents different in nature, resulting in the no plane of symmetry, it is said to be chiral. And the chirality generally develop in the nitrogen due to the Walden inversion, or that is nothing but the rapid inversion of amine to its lone pair. And in this case, when there is four substitutions are different on the quaternary ammonium nitrogen, it's said to be chiral. Thank you guys. Hope you like my video. Please share and subscribe.